Welcome to Study Loop.
So now we'll work on problem 104 from chapter 17. So in this problem, we're given a concentration of an ionic compound, and we're asked if we have a precipitation agent given in the right, what is the concentration of that agent we'll need to begin precipitation. So, or to begin precipitation of the metal cation. So in the first example, we or the cation in general. So the first example, we have barium, and that would be precipitated by fluoride. So we need to write the KSP for barium fluoride. And that's equal to 2.45 times 10 to the minus 5. So precipitation occurs when Q is equal to KSP. So we can say mathematically that Q is equal to KSP, which is equal to 4S cubed, or better yet, we'll say it like this: barium concentration times fluoride concentration squared. Now, we're given the barium concentration from the beginning is 0.035. And that, of course, is fluorine concentration is what we're solving for. So we divide KSP, which is equal to 2.45 times 10 to the minus 5. We divide KSP by 0.035 and take the square root, and that gives us the concentration of F minus necessary to start precipitation, which is 0.026 molar, so a fairly high concentration. For part B, the compound is calcium sulfate. So we're going to go ahead and write down, or the compound that will form the precipitate is calcium sulfate. So we write down the KSP, which is 7.10 times 10 to the minus 5. And then we'd follow the same process. Q is equal to KSP, which is equal to 7.10 times 10 to the minus 5, which is equal to the concentration of calcium, which we're given as 0.085, times the concentration of sulfate. So when we solve for the concentration of sulfate by dividing both sides by 0.085, we get 8.35 times 10 to the minus 4 molar. And so for the last part, part C, our potential or our precipitating compound will be silver chloride, which has a KSP of 1.77 times 10 to the minus 10. We perform the same calculation. We get 1.77 times 10 to the minus 10 is equal to the concentration of silver times concentration of chloride. No exponents, since we have a 1-to-1 ratio here between the ions. So the concentration of silver is 0.0018. Concentration of chloride is what we're solving for. And so when we divide both sides by 0.018, we get 9.83 times 10 to the minus 8 molar. So since our compound has a low KSP, we need a very little to start precipitating the silver chloride.